Welcome to this new video where I will explain how to use this library, which is JUnit for AnyLogic 6.0.1, which is today the last version of JUnit. In general, setting up JUNIT6 in AnyLogic is quite complicated and you have to do a lot of stuff. And the idea of this library is to avoid you doing this stuff, and this comes with everything ready, everything you need. Additionally, we'll have some README documentation. We'll explain everything that you can do in the library in here, but we'll do few videos later to explain more of what you can do with JUnit, especially in AnyLogic. And here we have two example models so far. We might put more in the future, but for now you have two example models where you can see how JUnit is used in AnyLogic. So with that being said, let's get started. Okay, here we have a completely empty model in AnyLogic, and the first thing we need to do in order to use JUnit6 is to bring our library. So this one, and will be added as a dependency for your project. Okay, so next step, we'll add a custom library. Let's call it tester, and we can erase everything that is in here. All the setup is done separately. Then we'll create a new custom experiment that is called run all tests. We can delete all this as well. And finally, you need a Java class that will have your tests. Let's call it test class. And we can erase everything really. So in this test class, all our tests will live, but you can have many classes with different kinds of tests. The next thing is in run all tests. In the import section, you will need to import JUNIT6 for AnyLogic. And in order to run the test, we'll do this: AnyLogic JUnit launcher dot do test. The argument for this method is the test class dot class. And this is all you need to run tests. I can already run this, and you will see that all tests passed because there's actually no test, 0 out of 0. So the most important annotation is the test annotation. You will see that this is contained in org unit jupyter.api. You need to import this because it's not done automatically, unfortunately, but you can easily do it. And after the test, we'll create a function that is a test. So let's call this public void add test. So when you call this method for this particular class, this will run all the tests that have this annotation, or all the functions that have this annotation. Right now inside this, there's nothing. So if I run this, now instead of 0 out of 0, it will be 1 out of 1, because there's one test, but it passes because there's nothing to do here. So one of the most important things is using assert. In order to use assert, you need to import all this stuff. When you import this, you will have access to the asserts. So let's say that in main, you have a function, returns a double. It takes 2 arguments and returns a plus b. And I will do it static, so I can call it directly in my test class. So here, the result will be the addition of 3 and 2. Then I can use assert equal that takes the double expected and the double actual. So the expected is 5 because the addition is 5, and the result is actual result. Now I run all tests and you will see that I passed. But let's go to the add function, and let's say that you made a mistake and you added +1 here. Now I run all tests and some tests fail. The test that fails is add test, because the expected was 5, but you got 6. But I haven't used the tester experiment yet. So let's add all this stuff here, and let's explain a little bit. So root is main. The engine is the experiment. These are global in the test class. Now we use the before each annotation. Before each test, we want to run a simulation. So what we're going to do is we will create a new experiment. We'll define the general things. So this will run for 1 hour. And the root will be a new instance of main. And then you start the engine. This will run your simulation model. Now, of course, if add is not static, then I will get an error here. So what I want to do is use this root. So instead of main with an uppercase, I will use root because I already created an instance of main. But before that, we need to run the simulation. So we will only get this result at the end of the simulation. Now, in this case, it doesn't matter, but this is an example when you want to run the simulation that is doing things with time, and then you get the result at the end of the simulation. So if I run all tests, you will see the same error. Now we can create another function here to subtract, and it will return a minus b. We do the subtraction test. We'll do the same thing, run fast, but instead of add, we'll do sus, and the result expected is 1. Now I run this, and this test failed. Of course, I haven't changed, I haven't corrected it, but let's correct it. And now both tests passed. So you can see that I didn't do any effort, and just by using this test annotation, my experiment ran all the tests associated to this class. But I can do this instead of here, I could do it somewhere else. So let's create a new class, and here I will do the add test, and in the other class, I will do the subtraction test. If I do this now, I will get only 1 passed for test class. In order to run both, I would have to go here and do the test for the other one. And I run all tests, and I passed 1 for test class and 1 for second test. That's it.